Let's start from the basic network. So how a network is built upon. Definitely our endpoints are some computers, right? Need not be computers, it can be any machines, any device which can exchange some data. So it can be server, it can be PC, it can be smartphone, laptops, right? All these comings under the endpoints of these networks, and all these devices are interconnected using some sort of media, some sort of links. It can be either wired or it can be wireless media. And these devices are actually interconnected with the help of some interconnecting devices like switches, Wi-Fi, modem, etc. Right? Router, gateway, etc. are interconnecting devices. And all these together forms a network. So we can briefly say that a computer network is a set of devices which are called actually nodes which are interconnected by communication links. So a node can be a computer, printer or any other device capable of sending and or receiving data generated by other nodes on the network. And what about the links? Links can be cable, air, optical fiber or any medium which can transport a signal carrying information. So this is a definition of a computer network. So in brief, we can say that a network consists of a set of computers and connecting media, communication media will be there. And of course, there can be some interfaces, right? We cannot directly plug a device using this cable, right? Some sort of interface will be there. So like a network interface card, or nowadays we are having network adapters coming as part of motherboard. So those are interfacing devices. Then interconnecting devices, we cannot always directly connect different computers. In between we have some connecting devices like hubs, switches, repeaters, etc. So those are called network connecting devices. And of course we have a communication software. So we are trying to connect two different machines, and this machine may be entirely having heterogeneous, like the OS may be different, processor may be different, everything may be different. So how to communicate between two entirely different systems? So we need some software to provide this communication between heterogeneous compute, and those are the communication software. So all these together forms the computer network. So the first component is set of computers or nodes, and second one is communication media. And how will you define or how will you categorize different medias? So we can say that the entire transmission media can be categorized as either guided media or unguided media. Okay. So in case of guided media, the signal transformation or signal transfer is done through some physical media. There will be some physical path or conduction material will be there, like twisted pair cable, coaxial cable, optical fiber cable, etc. Those are guided media. And in case of unguided media, the signals are transferred through some wireless medium like radio waves, microwaves, infrared, etc. So these are the different medias. Then network interface cards or network adapters. So we need some interface, right, in order to connect the device to this media. So we are cabling here into this Ethernet port, which is internally connected to some interface, right? Some circuits will be there to connect this media or cable to this machine. So these are network interface card, or we will have some network adapters. So those are interface. Then interconnecting devices. So depending on the use of this connecting devices, we can classify these connecting devices as either networking devices or internetworking devices. So if we are using those devices to connect to different nodes within a network, we can say that those are networking devices. And if those devices are used to interconnect two different networks, in that case we are calling those devices are internetworking devices. So within a network we are using different connecting devices like repeaters, bridges, etc. to connect different parts of a network, whereas two different networks are interconnected using internetworking devices like routers, gateways, etc. And now, how to categorize networks based on the span or scale or the area covered by the network? We have different categories starting from PAN, that is personal area network. Then we have local area network. Then MAN, that is metropolitan area network. And finally, we have the wide area network or WAN. Now, coming to personal area network. That is usually a network for a personal use. Just for a person, we have a small network like he is connecting his PC, laptop, his mobile phone, printers together for personal use. Such a network, small network for personal use is called personal area network or PAN. Now coming to a little more larger, which covers an organization like it can be a school, banks or some campuses, colleges like. So all the devices within that building or within that organization connected together forms a LAN network. The typical speed of a LAN usually will be 10 to 100 megabit per second. So compared to other MAN and WAN, the speed of this LAN will be higher. So here we are showing an example for an Ethernet. Okay, that is LAN. Now MAN, the coverage or the area covered by the network is little bit more compared to LAN. So this is usually designed for some cities in which a set of LANs are there. Just for example, a metropolitan city in which we have multiple banks and each bank is having a separate LAN and all those LANs have to be connected together for communication. So in such case we can use a MAN, that is we are connecting different LANs together to form a single network, that is MAN. And the final one is WAN, which the span is more, maybe a country, all the networks in a countries are connected together. So we have a network subsystem or communication subsystem in which different LANs are connected through using some gateways and all. So firewalls will be set according to the privacy and security required. So we have a larger network, that is WAN. Now another category or classification of networks based on how different devices are interconnected. Whether they are always connected, two devices are always connected by a dedicated link, or there are the same media is shared by multiple devices like that. So based on that we have two different categories. First one is point-to-point networks and the second one is multi-point network. Okay. So in the point-to-point networks, we can see here there are only two different persons communicating each other. So there is a direct link or direct connection between these two persons, right? Like that, if you are having two different devices and these two different devices are connected by a dedicated point-to-point link, that means that link is shared by only these two persons or two machines. Okay, the entire channel capacity is used by these two machines. In that case, we can say that this is a point-to-point network. Now think about another scenario. There are multiple persons. See, these three different persons are communicating each other. So definitely there should be some method to resolve collisions and all, right? So we cannot have in that point-to-point connection there. We should have to go for some other method. So one way of connecting multiple devices together is shown here. This is a bus topology. We can see it later. So the same cable or same link is shared by multiple devices using some tapping and all. They are connected. So this channel capacity is shared among these four different devices. So definitely the collision, that is if multiple devices try to communicate simultaneously, the chance of collision will be there. So such things will be resolved, should be resolved here. Okay, so such configuration in which multiple devices share the same media That is called multi-point network. Now, based on how different components are arranged physically, how they are aligned, physically placed, we can categorize different networks. So different topologies are there like mesh, star, bus and ring. So how these different nodes and links are physically organized. Based on that, we have different types of networks, and these configurations are called network topologies. So 4 different topologies are there: mesh, star, bus and ring, and we can have a combination of these also. So starting from mesh topology. So in the case of mesh topology, you can see here 5 different nodes are interconnected, and there is a point-to-point dedicated link between every pair of nodes. See, every pair of node is interconnected by a dedicated point-to-point link. Okay, so in a fully connected mesh with n nodes, we need to have n into n minus 1 by 2 links, right? For every node, n minus 1 neighbors will be there, n minus 1 cable should be there, right? And in most of the cases, these cables will be full duplex, two-way communication is possible. So total number of nodes will be, total number of links will be n into n minus 1 by 2 links. And usually this type of topologies are used in connection of telephone regional offices. So in such cases, these all regional offices should be directly interconnected. Every pair should be directly interconnected. In such case, we can use this mesh topology. Now coming to the pros and cons of this mesh topology, the first advantage is that this dedicated links, right? This dedicated links between every pair of devices, which guarantees that each connection carry its own data load, right? Thus eliminating the traffic problems. And mesh topology is robust. Robust in the sense, if one link becomes unusable, it does not incapacitate the entire system, right? Only that link is affected. Only that machine which connected using that link will be affected. And we can see some alternative path also. And third one is privacy or security. With every message travels along a dedicated line, only the intended recipient sees it, right? So no other device sees a message. And physical boundaries prevent other users from gaining access to this message. Finally, there's a point-to-point connection, which helps in making fault identification and fault isolation easy, right? Traffic can be routed to avoid link with suspected problems. So this facility enables network manager to discover the precise location of the fault and aids in finding its cause and solution. Okay. And coming to disadvantages, definitely between every pair we need a cable, right? So more amount of cabling is required, and each device should have that much IO ports. Each device is connected to n-1 other devices, so that much IO ports also will be required. So definitely expensive. That's a major drawback. And also the size of the network will be more, right? That much amount of cables should be there, so size of the network also will be more. Those are the main drawback of this method. Now coming to the second topology, that is star topology. In this you can see that every device is connected with a dedicated point-to-point link to a central hub, central controller called a hub. So the devices are not directly interconnected, they are connected to this hub. And this controller acts as an exchange. It receives data from one machine and it will forward that machine data to some other machine. Okay. Now coming to the pros and cons of this star topology, you can see that compared to the mesh topology, the cabling required is less, right? So less expensive, and size also will be compact compared to this mesh topology. And each device needs only one link and one IO port to connect it to any number of others, right? So this factor also makes it easy to install and reconfigure. Any number of devices can be easily accommodated depending on only on the hub, capacity of the hub. And other advantage is mainly the robustness, right? If one link fails, only that link is affected. No other machine or no other communication path is affected. So identification of fault and fault isolations are easy. And as long as the hub is working, it can be used to monitor link problems, right? So what can be the disadvantage? Yeah, the central point of failure, right? If the hub fails, everything fails. That's a major drawback here. And this type of topologies are mainly used in high-speed LANs. Okay. Now the third type of topology is bus topology. In this case, we'll have a long cable, backbone cable, into which different stations are connected using some taps and drop line. Okay, so this is called bus topology. The drop line is actually a connection running between a device and the main cable, and tap is a connector that either splices into the main cable or punctures the sheathing of a cable to create a contact with the metallic core of the backbone cable. And as the signal travels along this backbone, what happens is its energy is transferred into heat. Okay, therefore it becomes weaker and weaker as it travels further and further. So because of this, there is a limit in the number of devices that can be tapped into backbone cable and the distance between these two cables. There is a limit. So depending on that, in a given length of main cable, there will be a limit on the number of devices that can be attached. And coming to the main advantages of this method, ease of installation, right? Any devices can be directly plugged into this backbone cable using this taps and drop line. So that's the main efficient or main advantage. And also less cabling is required, right? Only one backbone cable is required and drop line is required. So next, the drawback of this method, difficult reconnection and fault isolation. So initially this bus will be configured in an optimal level. After that, it will be difficult to reconfigure it. If you want to connect more devices, it will be difficult, right? And fault isolation is also very difficult because there's a backbone cable. If there is a break in the system, that will make the entire communication fail, right? It's very difficult to find out where the corresponding fault occurs. So fault identification and isolations are very limited. And as you told earlier, the tapping that create a signal loss there and signal reflection at the taps can cause degradation in quality. So this will limit the number of devices which can be connected to the given length cable. Okay, so these are the different drawbacks for this bus topology. And finally, we have the ring topology. So you can see in the figure that in this case, the different devices are arranged in a logical ring. Physically, there can be any structure, can be linear or any type of arrangement, but logically they are arranged as a ring. That means every station is connected to its immediate neighbors to the left and right. Okay, and a repeater is there. So we have a main cable and each device is connected to this cable using a repeater. Repeater is actually used for regeneration of signals. It's not an amplifier because the signals are always traveling through this ring. Okay, and there can be a chance of degradation. So what we are doing is using this repeater in every station, the signals are regenerated. That means the zeros are generated as zeros and ones are made ones. That is a function of repeaters. Now, if a station wants to send some data to some other station, it will send the data to its immediate neighbor. So the data flow will be always in one direction, either in clockwise or anti-clockwise. Suppose we are selecting a clockwise communication path. And suppose this station wants to send some data to this station. what it will do is it will forward this data to the station, and this station will check the destination address of the data received, and if it is the same as that of itself, it will just accept the data, otherwise it will just forward that data, and this procedure will be repeated until the corresponding data are received by the actual recipient. This is how ring topology works, and this is mainly used in IEEE 802.5 token ring method. Now coming to the main benefits of this ring topology, definitely the cabling required is less, right? And ease of installation and reconfiguration. So if you want to reconfigure after installation, also if you want to change or if you want to add more devices, only 2 different connections are to be done, right? That is, reconfiguration is easy, installation is also easy, and easy fault isolation, because always the signals travels along one direction, and if there is some problem in the network, okay, that is, if one device does not receive a signal within a specified time period, it can issue an alarm because its immediate neighbor is not responding or the corresponding cable is broken. In that case, it can generate an alarm, and this alarm alerts the network operator to the problem and its isolation. And what are the major drawbacks for this method? Definitely this unidirectional traffic, right? Even if the data to be transmitted is to the immediate neighbor, and if it is at the opposite direction, then we have to wait for a long period of time. So this is a drawback. And break in the cable can disable the entire network. That's also another problem with ring topology. Now we can have a combination of these different topologies depending on our application. So you can see a combination of bus topology and star topology, right? Like this, we can combine different topologies together. That is called hybrid topology. So we discussed about different components of our network, and the last component we didn't discuss yet, right? That is network software. Definitely that's very important, and we have a lot to discuss about network software, and that will be discussed in the next session. Thank you.